Hey guys, it's on to Unit 6, Lesson number 3. Today we're going to use the central limit theorem to solve problems involving sample means for large and small samples. Guys, what we've been doing is solving different problems for one sample. The only change that we're making is we're actually going to have more than one sample here, so it's actually not going to be all that bad. But you do need to know a little bit about the central limit theorem first. So first off, the central limit theorem says the following: as the sample size n increases, the shape of the distribution of sample means taken with replacement from a population with mean mu and standard deviation sigma will approach a normal distribution. This distribution will have a mean mu and a standard deviation of sigma divided by the square root of n. So guys, all we're really doing now, instead of having a z-score of z equals observed minus expected over the standard deviation, now is where this standard error comes into play. The standard deviation is going to be sigma divided by the square root of n. So the bottom of that formula is just going to be sigma divided by the square root of n. Everything else stays the same. Okay. So our z-score is observed minus expected over the standard error, which in this case is going to be x bar, the observed, minus the expected, which is mu, over sigma divided by the square root of n. Okay. Sampling error is just simply the difference between the sample measure and the corresponding population measure due to the sample not perfectly matching the population. Basically, guys, this is your sample error. Okay, so let's do a couple of example problems with this. The average American ages 18 to 25. So your all's, almost your all's age. Eats 137 hamburgers. Per year. With a standard deviation of 24. If we pick a random sample, of 36 people, ages 18 to 25, find the probability they eat on average A, less than 130 per year, B, between 125 and 140, and C, over 145. Okay guys, so these problems are exactly the same as what we've been doing. The only difference is now we have more than one sample. We have 36 samples here. So again, I strongly encourage you, draw your picture first. It's always going to look like the standard normal curve. Okay? The mean is always going to go in the middle. The average in this case is 137. Now, we are doing, we wanted first less than 130. Well, 130 is to the left of 137. And we're doing this. So this is our data. We need to standardize this by finding the z-score for 130. So the z-score for 130, but the fact that we have 36 samples now means that we're going to have to actually use this other equation. We're going to have to include that 36. But everything else is exactly the same. The observed is 130. The expected is 137. The standard deviation was 24. So we have 24 divided by the square root of n. N was 36. So that gives us a z-score of -7 divided by 24 over 6, or -7 divided by 4, or in this case, -1.75. That's our z-score. Okay, that is the z-score for part A. Now, since we know the z-score, we take our blue chart and we zoom in here and we find -1.75. Well, here's -1.7, and -1.75 is right here, 0.0401. Okay, so our answer for this problem is 0.0401. And that's it. Well, how would we do between 125 and 140? Again, as always, draw your picture first. Draw your normal curve. Put your 137 in there. Where are you? Well, 125 is to the left of that. 140 is to the right. So we're going to have to find the z-score for 125 and the z-score for 140, and because we want between them, we're going to shade this in. Guys, this becomes so much easier if you just keep doing it over and over. Draw that picture. So find our z-score for 125. Well, z is 125 minus 137, and I still have 24 over the square root of 36. So I now have negative 12 over 4, which happens to be negative 3.00. Our other z-score is going to be 140 minus 137 over 24 divided by the square root of 36. That gives us negative 3 over 4, or negative 0.75. No, it's positive 3. Sorry, positive 0.75. Now, again, use your chart. Negative 3.00 is right here, so I have 0.0013. So the probability of this is 0.0013. The probability of 0.75 using the chart ends up being 0.7734. Now remember, okay, and this is where it gets tricky for some of you sometimes. 0.7734. That is everything to the left of 140, including all this that I didn't shade in. 0.0013 is everything to the left of 125, so the amount that I didn't shade in is 0.0013. What I do want is I want everything between these two. So if I take these two numbers, the number for 140 and the number for 125, that will give me the area between these two curves, or the probability, which is 0.7734 minus 0.0013, or simply a probability of 0.7721. Guys, I hope you're finding that these are getting easier and easier as you keep doing them. Okay? You just got to keep doing them. Let's do one more. Let's do part C over 145. So over 145. Again, draw your picture. 137. Here's 145, and what does it say I want? Over, so that's to the right. Okay, so I'm over 145. My z-score is going to be z equals 145 minus 137 over 24 over the square root of 36 still, which is simply going to be 8 over 4, which equals 2. So at 2.00, my probability is 0.972. Okay. Remember, this z-score of 145 is 2. So the probability of everything to the left of 145 is 0.9772. That's to the left. I don't want to the left of 145. I want to the right. So how do I figure that out? Well, remember, the area under this curve in total is 1. So all I have to do, guys, is take 1.0000 minus 0.9772. And I end up with 0.0228. Now somehow some of you are coming up with like 5 digits or 6 digits out here. Guys, just use what's on the blue sheet. Use your 4 digits. If you're using a calculator program or something like that, stop. Don't. Just use these 4 digits. Okay? Now don't use less than those 4 digits, because a couple of you are rounding it up too much. Okay? All right. We're going to do 2 more problems, but there's going to be a little bit of a difference here, because with these 2 problems, there will be some interactions in the video for you to take, and then you'll get a chance to, then your answer will be checked almost right away for you. Okay? So let's do number 1. or the second example, whatever you want to call it. By the way, because of the interactions in the videos, I'm not going to be posting your homework until Tuesday. And on Wednesday, there's going to be a little short quiz that you have to do on Wednesday. And that will be it for your grades for this term. So, and of course, you know there's no school Thursday, Friday, Saturday, Sunday, or Monday for you guys. All right. So then nothing will come up until next Tuesday. Later on Monday, I will be posting some videos of me working out the problems that you guys seem to be that you guys had with the first two work sections. I know a lot of you had a problem with the last problem where you had to find the middle 50%, and I'll be happy to go over that. But I'll go over that in a different video. Okay. The average sneeze spews mucus 4.3 feet through the air in a normal distribution with sigma equals 1.1 feet. If 5 people stand 4 feet from you all sneeze, what is the probability their mean is under 4 feet? All right, guys. Once again, what am I going to tell you to do first? Draw your picture. Okay. So when you draw your picture, this is sort of what it should look like. What goes here? What goes here? And where do I shade? Okay. Hopefully you were able to fill this out on your own. The first line is the mean, that is our average of 4.3. This line is how far the people are standing from you. It's 4 feet. Okay? And I want that their mean under 4 feet, which means I want to the left of 4 feet. So how do I do this? Okay. Well, as you know, my z-score is observed minus expected over the standard error, which in this case is x bar minus mu over n divided by sigma divided by the square root of n. Now, hopefully you fill this in with the following. 4.0 is how far they are from you. 4.3 is the expected. And you should have 1.1 over the square root of 5. If you do the math here, that should come out to be negative 0.61. Now, what do you do with negative 0.61? Well, you go onto your blue sheet. What is P for a z-score of negative 0.61? Hopefully, when you all look this up and answered the multiple choice question, this is what you got. So the probability, it's a 27% probability that their mean is under 4 feet, which means it's a much higher probability that they're going to sneeze on you. Ew. Okay. Last example for today. A family of 4 spends an average of $587 per month on groceries. This distribution is normal with sigma equal to $73. If a random sample of 20 shoppers are surveyed, find the following probabilities. A, their mean is between 575 and 600. B, their mean is over 550. Okay, ladies and gentlemen, what's first? Hopefully, you said draw the normal curve. Hopefully, when you draw your normal curve, you fill out the parts of the problems that you're being asked for. 575, and this was 600. And again, they went between those two, so let's go between those two. How many z-scores are we going to have to find? Correct, 2. Z equals 575 minus 587 over 73 divided by the square root of 20. Okay. So that gives us negative 0.74. What's the other z-score going to be? Hopefully, you figured it out after writing down the formula. Hopefully, you came up with 0.80. Okay, the z-score, or the probability for negative 0.74, again, this is something that you needed to figure out, was 0.2296, and for 0.80, 0.7881. What do I need to do? Again, 600, this 0.7881 is everything to the left of 600. This 0.2296 is everything to the left of 575. So again, just subtract those two numbers and I get what's in between. 0.7881 minus 0.2296. Now for part B, there's going to be a lot of interactions. I'm just going to be drawing in between the interactions, so you won't actually hear me talking. Hopefully with all the interactions you were able to come up with 0.9884 as your final answer for part B. Alright guys, that's it for today. I've already told you what's going to be happening over the next week. Be prepared for a little quiz on Wednesday. Hopefully this should be pretty straightforward for you. Alright guys, have a great day.